And I know I need to share computer sound. There we go.
Hi, my name is Rob McLeod from the University of Utah. I'm a professor of biomedical engineering, and my job today is to tell you a little bit about our program, the biomedical engineering program at the University of Utah, and describe what the field is, describe a little bit of the background, and then explain to you a few of the details of our specific program. There'll be lots more information, lots of other tips you'll get, more specific information you'll get, and I encourage you to follow up on that. Our department really began with this man you see in front of you. This is Willem Kalf, who was a Dutch scientist who really was the pioneer, arguably, of artificial organs. He had many early artificial heart designs, then moved into dialysis, and had a major role in the history of artificial organs here in Utah. The Barney Clark adventures, the very first completely implantable artificial heart, and that legacy continued for quite a while after he left and moved to another university. And a modern version of that, if you will, is this electrode array, also developed by a now retired member of our faculty called the Utah Electrode Array, which is an implantable array that's placed in the nervous system of the human, in the brain, in some peripheral part of the system. Here you see it controlling a robotic arm by thought. The woman, the subject here, is actually just thinking about moving that robotic arm and feeding herself that wonderful chocolate bar. We also do a lot of modulation of the brain from remote sources as well as these implantable sources. This is an image from modulating, really injecting current into the brain of a subject. And we can use this to modify many conditions, motor neural diseases, but also behavioral problems, even depression, using non-invasive techniques with electric and magnetic fields. Orthopedics is also a big area of emphasis in our department. Here you see some simulation results from a patient-specific model of a hip joint, with the idea that we can intervene early. We can guide the surgical intervention so that a hip replacement, a full hip replacement, is not necessary down the road by making smaller surgeries early on in the course of events of a patient like this. We also do a lot of fundamental research in the behavior of the heart. This is a picture of a heart in an animal study in which we're recording the electrical signals from the surface of the heart, recording it over time, intervening in that heart, creating different conditions that mimic the human pathology of the heart, and trying to understand its mechanisms and how to better detect it when it arises in humans. And finally, we do a lot of studies in which we study things at the cellular scale, at the tissue scale. We do a lot of tissue engineering and modeling of tissue, creation of tissues, reprogramming of cells. And this is just one image using some of the very beautiful fluorescence imaging techniques that we've developed to track the behavior and the action of these cells in animal or tissue preparations. So it's a very wide, very diverse set of research that we carry out here at the University of Utah. One of the strengths of the program is that students get to experience this research in a first-hand way. Now, fundamentally, what is biomedical engineering? It really builds on the fundamental concepts of physics, chemistry, and math. This is why we require some initial training in these major subjects. But then it applies, and that's what engineering is really all about, taking these fundamental fields and applying them to solve problems that are maybe more practical in focus rather than fundamental in understanding, let's say, the physics of the universe. So here we have 5 of the standard engineering disciplines, and biomedical engineering really combines elements of all of them. So we give students exposure to some level of detail at each one of these areas, and then help them translate the fundamental knowledge using the techniques of these engineering skills into the fields of biology and medicine. And so we understand fundamental concepts in biology. We can improve the understanding of mechanisms of the body. We can also guide physicians and guide the understanding, the diagnostics, the therapeutics that are involved in medicine, and really make a difference in people's lives. There are many subspecialties within the field of biomedical engineering, and they kind of map back to those basic engineering disciplines that you probably all know about. And again, we expose students to each one of these various subspecialties in basic courses, but we also allow some deeper training into each one of these areas, as well as many more subjects that come up quite naturally in the field of biomedical engineering. It is a very broad discipline. One of the challenges is exposing students to enough, but then allowing them to specialize enough to really move forward in a discipline, in a career. We also love to advertise that at the University of Utah, we're a very affordable option. This is a graph showing the in-state tuition rates of a number of universities across the country, many leading institutions, as you see here in the bottom of the graph. And Utah is really at the very lowest of this. So we're a very affordable option. We give a quality product. Even our out-of-state tuition is much lower than many of our competing programs elsewhere in the country. So it's not only quality education, it's also a high-value education. It's a very affordable place to live, to work, and to study. Now, our students go on to great things, and we try and help them get to those great things. A substantial number go directly into industry. There are a number of jobs locally and remotely. Another substantial, similar size portion end up in graduate training. They go into typically biomedical engineering fields. Another, say, quarter go into medicine and health professions. It's a very important step forward. Ours is a wonderful program to facilitate that move into the health sciences. We have a very high overall success rate of enabling our students to get into medical schools and dental schools, somewhere in the order of 90% in most years. And then finally, we have another group of students who choose to go into business directly or to law school or one of the other related areas where they use their engineering knowledge in a even more applied kind of setting, away from the engineering and more in the management aspects and the legal aspects, the intellectual property aspects, for example, of engineering, and especially biomedical engineering. We have a high success rate in placing our students in what is a very rich environment right now. Job opportunities are very good for the biomedical sciences. Generally, you see here 72% is the growth, and that was expected has largely been realized in the field of biomedical engineering. Salaries are in very good shape. There are many accessible job opportunities, again, both locally, nationally, and even internationally for our field. So we're very happy about the prospects that we can offer students who want to pursue this particular specialty. There are a number of employers in the state, as I mentioned before. This is just a small list of some of the typical companies that we have in the state. Some of them are large companies like Bard Access and Beckman Dickinson and Edward Life Sciences, and others are smaller startup companies. And so our students can often find both great employment opportunities and, while they're students, great internship opportunities, so they can experience the real world of working in an industrial setting and really get some sense of what it's like to be an engineer while they're still in training, while they're still deciding, should I go to engineering, should I do a master's degree, should I move into medicine? The program that we use to get students there is very diverse. The details here are not important, but we have a well-crafted plan with some flexibility in it. You'll see there are a number of electives here, technical electives, and we advise completely throughout the program as to how students can navigate this field of study. We build the program on a broad background, as you would expect, from math, chemistry, physics, and some biology, and then we add in the core areas, the core topics that really make up our discipline, and expose students to those areas. To get into the program, be a full major, that traditionally happens after the third semester as we move from the general courses into the more specific core requirements or core courses in the discipline. You'll see in the first 3 semesters, there's still biomedical engineering coursework involved. The students are always taking courses in our program. We always try and give them a sense that they belong to a program and really have a place in the big university they're living in. There are requirements, of course, for that transition, and those are well laid out in our handbook, which I encourage you to read in more detail. And then once a student passes into that full major category, then they will take a number of specialized courses that are introductions to the field, supplemented by electives, 15 hours of electives that really allow the pursuit of more specialized training and the preparation for the subsequent steps, whether that's industry or medicine or something else. Finally, we have a very rich and I think wonderfully diverse group of students in our program. Not surprisingly, we have the highest female to male ratio in the program. In fact, recently we had a majority of females in some of the pre-major courses. Still have a high percentage of females who get into the major. We also have a reasonably diverse group of students in the class. You'll see we have, a 35% non-white population, which is much higher than the state average in many of the programs at the University of Utah. Many of our students decide to pursue the honors program, which has advantages that we can get into in our more detailed discussions. And we have a very high graduating GPA, which qualifies the students very well for those next steps in their careers. Again, the additional training in engineering, the training in medicine, and even going into the workforce directly. So we graduate students who are well-trained, well-recognized as being well-trained, and who are highly qualified for the next steps in their careers. So how does the biomedical engineering program interface with medical school? How does that preparation work? Well, we designed the program from the start to interface very well with medical school. All the basic pre-medical requirements are covered either in the prerequisites for our program or in courses that students can take as electives in our program. So the physics, chemistry, basic biology is all a prerequisite, and then the electives that we introduce in the program all fit into the required and some of the sensible electives to take as pre-medical courses. Things like the organic chemistry too, the biochemistry basic training, and even the lab. All these things can fit very nicely into a biomedical engineering course of study and prepare the students perfectly for entrance into the medical professions. We also cover all the gen ed requirements that typically medical school requires. And we also expose students to research, which we find gives them a rich wealth of topics to use in their interviews and leverage really in having a very strong and powerful application for the medical school, because they have research experience, documented research experience that they can also discuss and talk about in their interviews. And the interview, as we know, is a very important part of medical school admission. We also have a combined BS-MS program, which is a very efficient way to get to the master's level. The master's is a very good sweet spot, very good trade-off between time invested in education and payoff in terms of excellent job opportunities. And we have an agreement with the university that allows the students to very effectively actually use some of the coursework for both the bachelor's and the master's program, and effectively within a single year beyond the bachelor's degree receive their master's degree at the same time, increasing their earning power, increasing their job opportunities in a very straightforward and easy to fulfill way. And this program is seeing dramatic growth in the last several years as we've fleshed it out and been able to show that it's highly effective in placing students in exciting jobs in industry. The research experience we think is very important for students. We have two major directions that goes in. One of them is the Biodesign class. This is a class, a 2-semester sequence that is really driven by real-life projects. These are projects not off the shelf, not things we know will always work, but projects that come from the medical school, from physicians, nurses, residents in medicine who have an idea and need engineering help to pursue that idea. So students work on real-world projects. They develop those projects. Some of them develop even spin-off companies and participate in those once they graduate. They certainly receive recognition for their intellectual property, which they maintain if they contribute and if what they develop comes to a disclosure or eventually to even a patent. So this is an incredibly popular program. And along the way, they also learn the skills required to make a product. There are legal requirements, there are testing requirements. The FDA is an important component of developing devices. And they learn all the correct and legal moves that it takes to generate a real product in the real world, making them very qualified then for jobs in industry. They know the process and they know the excitement of creating something really novel that hasn't ever been done before and that could really have an impact on medicine, on helping people, and on patients. The second great research opportunity that students have is called senior thesis or senior project. This involves students participating actively in research. It could be research in a local setting on the campus, in one of the labs like my own. and all my other colleagues. It could be a lab in the hospital. It could be a very clinical project. It could be a basic science project. The projects are incredibly diverse. The students spend the better part of a year getting research training, engaged in research. Often they can achieve independent funding while they're doing this research. And then they take the product of that research and, again, in a 2-semester course, learn the incredibly valuable skill of communicating that research, that ability to take an idea and put it into words and images as a poster, as a presentation, as a written document. It's certainly well known that one of the big growth areas in engineering has been the soft skills, the skills to communicate, the skills to engage with other people. And these are skills that come naturally in the setting of working in research, and that we specifically train by instructing the students in the practice of communication, of modern writing, presentation, poster skills in a whole range of different formats. So that when the students finish this course, they really are competent in their science and how to talk about their science. I have a wonderful team working with me as advisors in the program, and you'll meet some of them in the course of this orientation and really throughout your studies. Heather Palmer is the first. She's been in this program for a number of years. She has a master's in communications. She actually directs the senior thesis course. Kelly Broadhead is a PhD in bioengineering and teaches and does advising. He's in charge of the Biodesign program and has a great sense of the value of that program and how to make that exciting for students. Erica Fernley is the third of our advising team. She's a new member of the team. She comes with a strong background in communication and writing through her BA in English and is a wonderful addition to the team. And I have the pleasure of working with these people to provide for you the kind of guidance, the advising, the real hands-on interactions with every student in the program so that each one of them gets individualized attention. There is no single fit here. There is no single program of study that we have students pursue. In fact, every student must reach out to us, work with us, and enjoy the many opportunities that we have in the field. And we look forward to working with all of you students to help you develop your program and eventually your career in what is an amazingly rich and diverse and fascinating and fulfilling field called biomedical engineering. Thanks for your attention. It's been a pleasure talking to you.
Okay, so that's kind of the canned piece. I mean, it's efficient, pretty compressed sort of story of what our program's about. I'm Rob McLeod. I should have introduced myself before, but thank you all for coming in this morning. We have relatively short slots this morning for each of several different opportunities you have. Two of the aspects in the video that I highlighted have separate sessions as well. So the Biodesign program, Kelly Broadhead can tell you a lot about, and then one of our really interesting highlighted research areas that I mentioned very briefly about this computer brain interface, this human this way to bring technology control back to the lives of quadriplegics and paraplegics is something that Greg Clark will describe. They have an artificial arm that's also controlled through thought, through people actually desiring to pick something up, and that's received a lot of press locally and in the last couple of years, and he'll be describing that for you in a little more detail. We also, in all the three individual sessions are done, have kind of an open discussion space where we'll have breakout rooms and you can get specific advice on topics. So that's how we're going to organize things today. So for the time we have left now, before I have another shorter video to show you at the end, which is really a student perspective on our program. And but before then, happy to answer questions. I don't know, who's interested in what kind of programs. I'm sure if any one of you has a question, there'll be at least 4 others in the room, our virtual room here, that will be interested in the answer. So please feel free to jump in, either unmute yourself, which I think you can do, and ask a question, or put it in the chat window, and I'd be happy to answer that.
So, how exactly is physics involved in this field?
That's a great question. I love that question. I actually teach the course in the pre-major area that is all about applying physics to biomedical engineering. And so physics is a really big part of biomedical engineering in that it really describes, and this is what I actually go through in the course, everything to do with things like what a heartbeat is. The heart contracts, it creates pressures, it creates blood flow. That flow goes out into the vascular system. So we get into the physics of flow and flow in tubes that are compliant, that are flexible. So there's a whole bunch of mechanics that play into biomedical engineering very directly. And we have strong research programs actually both in orthopedics, so the study of bones, and people studying the mechanics of joints, how joints actually move in 3 dimensions and in time, and how to identify in patients based on, let's say, an X-ray or a CT scan, when there are structural abnormalities and what their consequences are. And then we also spend a lot of time in the context of physics talking about electricity. It turns out that all the thinking, all our nervous system, all our muscles, our heart, all those things have strong electrical components. Without electricity, most of our cells actually would not even function. So there's a lot of really interesting applications of electricity, current flow, voltages, all those things that you learn about in the sort of electricity and magnetism parts of physics. So those play a really big role. And you can even see our program and our discipline um, somewhat artificially, I wouldn't say hard divided, but we certainly have a large group of topics in biomedical engineering that are physics driven. We have obviously a bunch that are chemistry driven. And then we have some others that I would say are more, maybe more explicitly connected to math or more connected to fields like imaging, and certainly strongly connected to the whole field of computing and computer science and the use of computers. And like I say, these are not hard boundaries, and any student who comes into a program learns right away. Actually, in the first year, they already start getting a course in the chemistry-based approaches, and then in the sophomore year, I teach this class in the physics-based approaches. And then once in the major, you'll see a lot more specific applications of the fields like biomechanics, and we have a course in signal processing. We have courses in what are called biosystems. So it's really the electronics and instrumentations aspects, as well as the chemical areas, the materials, the tissue engineering, all these sorts of topics. Does that answer your question? You like physics so far?
No, it's so confusing to me. I'm trying so hard. I've been reading a lot of different books um, that talk about physics, so I'm trying to get more into it, but it's very hard to understand.
Yeah. Physics. Physics becomes, I think, much more accessible. I discovered this in my own class with my own students. We're just wrapping up our semester now. We have another couple of weeks. A lot of students really appreciate physics when they see how it applies to the body. So physics as a discipline, that's not everybody's cup of tea. But when you say, wait, this explains, how blood flows through vessels, or why my brain works, or how I feel things, how my sensations of touch and my muscle control all are controlled in lots of ways by physics, then it starts to make more sense and it becomes more
Yeah, it's
accessible.
super interesting. I just wish it would click better in my
Yeah,
brain.
yeah. No, we're I think pretty good at making it click. Okay, that was a great question. What else here? What are some things we should be doing right now in high school to prepare for majoring in biomedical engineering? This is a great question. Um, so what really helps, I think, in preparation are just a strong grasp of the, obviously the STEM fields in general, but students have challenges sometimes with things like physics, but I would say, really fundamentally, math is kind of important. I mean, we use math in all the areas of engineering, whether it's biomedical or other ones, and math takes a while to figure out. And sometimes it's not even the complicated math. It's not necessarily the integral calculus. It's really getting comfortable working with algebra, working with trigonometry, those topics that everybody gets in high school. I have to do little refresher sessions with my students to remind them how to solve equations, really just straightforward algebraic equations. So really getting comfortable with it, like not just knowing about it in theory, but really working through lots of problems and getting comfortable solving problems in algebra, problems in trigonometry. If you can, I know this isn't always available in high school, but some background in statistics is really useful. If you have any chance to get some statistics, we have one course in it in the major, but it's something that's, you know, talk about complicated. Statistics takes a long time to really understand in a way that allows you to work with it effectively. So I think math is really important, and I also actually think reading is really important. I think reading in English classes, literature classes, we have to absorb information. We have to convey information. You do a lot of writing. Believe it or not, you do a lot of writing as an engineer, and we certainly emphasize it in our program. So this is a skill that is important. And of course, you know, you have to be able to read textbooks and absorb information and be comfortable doing that. So you know, those courses I think can be just as important as the obvious STEM courses. Let's see what else is here. How is psychology used in this field? That's really interesting. So we don't, we certainly don't teach courses in psychology. I would say the where there is a lot of overlap. So there's an area of psychology that has to do more with the physiology of how the nervous system works, the physiology of behavior. And so there's a big field called neuroscience, and a lot of our students come through the undergrad program in biomedical engineering and then go on to graduate degrees in neuroscience where they can specialize in specific areas of the function of the brain. I would say that the psychology that the practical psychology that's really important and can be very challenging as a biomedical engineer is that we kind of have to talk to everybody. We have to be able to sit down with a computer scientist and talk, you know, pretty geeky about computer code, and then we have to go talk to a physician and understand how they think, how they operate, and that ability to really span this incredible spectrum from the very mathematical and technical to the applied areas of medicine and broadly science. I think that's really valuable for us and really important for us. So we do emphasize a lot communication skills, understanding how to interact with people, understanding the psychology of groups. The world of science and certainly the world of industry is organized around group projects. It's pretty rare to be developing a device all by yourself. It very quickly emerges out of that domain into having to work with teams because we have to interact with other specialties. So we get people working in groups very quickly, and you know, right away in the first year, they're already doing group labs and starting to build groups that way. We encourage students to form groups, to study together, interact together. We're very, very big on learning how to benefit from each other's strengths and how to teach each other. Turns out students teach each other sometimes better than we as professors teach them. We hopefully have a role to play still in education, but the interactions among students are super important. And so learning to interact with people, understand each other, have empathy for each other, you know, be supportive of each other. Those are, of course, right now even more important than they usually are. But they've always been a big part of our program. Let's see what else. Would there be an exoskeleton class, such as ones that Sarco produces? Yeah. So this is the area of orthopedic biomechanics. That's, you know, that's what the broad field is called, and we definitely have courses in biomechanics. As I say, I cover some biomechanics even in this basic pre-major course. One of the first courses you take in the major is in biomechanics, and that's really the gateway into that whole area. And so we have close ties with research labs in all aspects of biomechanics, whether it's designing replacement joints or trying to do better diagnostics of joints that are failing. That's all really part of what we do. So yeah, that's very much part of mechanics these days. does theoretical physics apply to biomedical engineering in any way? Well, yeah, it does. I mean, the theory of physics is builds the foundations. So even in my course, I talk about electric fields, which is pretty theoretical concepts, not something we bump into every day in our daily lives. So yeah, there's a lot of the theory of all these basic domains that we build on. But we're engineers at the end of the day. So engineers are kind of famous for building things, making things, turning theory into practice. So I studied physics as an undergrad student, and at the end of it, I thought this was really useful. I really enjoyed the theoretical aspects of it, but I really wanted to make things. I really wanted to do something tangible, something practical. I wanted to build devices that would have an impact on society and on people, and that's really what engineers generically do. So we can't do what we do without the theory, and so there's always a bit of theory in the education, but we try and move it into the practical applied domain, and that's sort of where our sweet spot is as engineers. What else here? Can you pursue any minor while getting a biomed major? This is a great question. We find lots of really interesting minors and even dual majors. I was speaking with a student just this week, so a lot of our students are getting ready to graduate right next spring. So I meet with all of them in this final year of their program just to make sure everything's on track for them. And I had a wonderful conversation with a woman who I think she was doing actually a dual major in ballet. So the breadth of minors and even dual majors is enormous. It's very, very typical actually for lots of our students to minor in music. Um, it's a great balance, I think, between the hard science, if you will, of engineering, and I think we really encourage that. So minors are absolutely compatible. There are obvious minors like chemistry, there are other scientific minors, but there's also some really interesting aspects to the university that you can take advantage of, even while you're pursuing a pretty challenging major like ours, that will fit in. There's some of the courses, it depends on the minor, but some of those minors make really good electives for our program. That can be some way to be a little bit efficient, at least about how you fit the minor into a pretty busy schedule. But like I say, we really encourage it. We also have varsity athletes. I mean, every year I have 2 or 3 varsity athletes in the program. They manage to find time to do that, and some of them maintain their varsity athlete status throughout the program. And I think it really rounds out people. We really like to see that aspect of diversity in our program as well. So that definitely works. Okay, so that's kind of what, excuse me, that's all I'm seeing in the chat right now. So please, if you have other questions, drop them in there. And yeah, anyone else have a question they want to ask right now? How many of you are thinking about math, for example? Let's see, you can click on there's a little reaction button down at the bottom of your screen. You can do like a thumbs up or something. How many think about doing medicine? You usually have, yeah. Usually have a fair number who think about doing medicine. That's great. It's a great major. Yeah, excellent. It's a great major as a pre-med major, and we do have a really high success rate. It is more challenging than some of the other traditional pre-major pathways through, let's say, biology or chemistry. Just because it is as diverse as it is, but we really do place a lot of students in medicine very effectively. And what the really cool thing is they get exposure to medicine, while you're still an undergrad. You could be doing research in a medical lab. You could be getting firsthand experience already in what it's like to be involved in medicine. And a lot of faculty that we have I have a secondary appointment in cardiovascular medicine. A lot of my research takes me into the world of cardiology and even very clinical projects in cardiology. And most of even the core faculty have these kind of ties to medicine. So it's a great place to get exposure. We also see students who come in thinking medicine and then get distracted by other things like research and trying to be industry engineers, and the other way around. And the program's very easily adapted to those changing, desires or changing ambitions as students go into the program. Okay, so I'm going to say, oh, minoring computer science, absolutely. We have lots of students. We do a lot of computing in the program, and I do a lot of computing in my own research. So we're very big on students taking anything from a single course that's sort of a requirement all the way up to a full-on minor. So that's definitely a possibility, something we really encourage. Sounds great. So, so I'm going to wrap up. Yeah, our chair has just arrived. Dr. Granger is there. You can see his picture, and he just popped into the chat list, pointed to our website. That's a really useful resource. Has all the information. Also has contact information. So if you go to the undergrad resources page, you can find links to those people I mentioned in the video, and really encourage you to reach out to us, find out answers to your specific questions. We have a handbook, of course, that you can go through, and we try and make that a useful material as well. And then maybe as we wrap up and as the new folks come in, I'll jump over and we'll show you another video that we just finished making. And I like this one because it's really a student perspective. You'll see these are real life students. We're not faking this. These are real life students. One of them is in my class right now. I can vouch for her. And the others two are seniors about to graduate. And it'll give you a little sense of sort of how the students perceive and enjoy our program. So let's have a look at that.
The Department of Biomedical Engineering is top-notch. One of the best departments at the university, I would say.
I would highly recommend it to anyone.
It has really increased my perspective on things and contributed to the growth that I now see in myself.
I enjoy the Department of Biomedical Engineering. Biomedical engineering is really cool because you get to take engineering and you get to take medicine and you get to combine it all together and really see the real world application of engineering in practice. The department itself, the classes are rigorous, they're challenging, but it's also very rewarding.
Right now in my classes, I find that my physics classes are relating to my biomed courses, which are all drawing back to the cell bio that I'm taking. And it actually gets me more excited for my major as I know that I'm learning things that I'll actually be using.
I've learned so much about what it means to be an engineer, as well as how to be a successful scientist.
The professors in biomedical engineering care a lot. They want to see you succeed.
I can tell that my professors, they really care. This year has been difficult with COVID and with switching everything to online. And all of the professors have shown a lot of care about the students. I can tell that they want us to be successful academically, as well as in our own life.
My professors are obviously passionate about their field and their line of work. I love to hear when they talk about their research and how pumped they get for their subject. I think that they are very accessible because you feel like you can ask questions and they will just willingly respond to anything that you have.
Also have personality. It's fun to see that in the classroom, whether it's on Zoom or in person. The advisors in the BME department are awesome. They are real humans that give great advice. Whether I need help organizing a class schedule or I'm having some personal issue, they're always there and they have great feedback. They've recommended some classes that I love and they've helped me work through a couple tight situations.
They know their stuff, by the way. They know like the courses in and out and they've seen all the different routes. So if you need help, if you need advising, go to the advisors.
The University of Utah is an excellent institution. I really appreciate their focus and emphasis on research, as well as their proximity to the hospital. They have their own dental school, and I feel really confident that it's giving me the skills to be successful in my future career.
They have provided so many opportunities for you to be able to explore and to grow, and there are many resources available that are meant to help you thrive.
The University of Utah campus has created a safe environment for me to do my classes, feel included, and provided a diverse space for me to explore my major, explore life outside of my home state, and kind of just create a new home away from home where I can learn to be myself and find who I am.
All right, so thanks so much for coming. I guess we're doing sort of a switch over here. There are at least 2 other sessions planned, so I encourage you to check those out. If you have other questions, feel free to reach out to me. And I see, yeah, Dr. Granger's adding in some comments here. Great. So like I say, feel free to get back to us. We will have a session around noon where you can come and answer or ask specific questions, meet some of our advising team, and hopefully get whatever information you need to have a look at our program. So thanks so much.
I'll hang by. Hi, thanks, Rob. This is Dave Granger. I'm the chair of the department. Work closely with Rob, who's our associate chair, and we're happy to host you here. And I would be delighted to try to answer as many things in the chat as I can type. And you're welcome to stay on board here, and we can try to answer questions for those who want to stand by. Remember that there is a Q&A session and a general information discussion for biomedical engineering that's queued up at noon. So that we'll see you then if you have further questions and interest in our program. Thanks for coming.